Let us now familiarize ourselves with a few terminologies in natural language processing. Term document matrix. A document term matrix or term document matrix is a mathematical matrix that describes the frequency of terms that occur in a collection of documents. In a document term matrix, rows correspond to the document in collection and columns correspond to the terms. There are various schemes for determining the value that each entry in the matrix should take. One such example scheme is the TF-IDF, or the term frequency inverse document frequency. They are useful in the field of natural language processing. We can consider a document term matrix DTM as an implementation of the bag of words concept. Term document matrix is tracking the term frequency for each term by each document. We start with the bag of words representation of the documents, and then for each document we track the number of times a term exists in that document. A document term matrix can become a very large sparse matrix, which means a matrix in which the majority of the values are zeros, depending on the number of documents in the corpus and the number of terms in each document. Sparse matrix may be formed. Considering that our data is a collection of tweets in text format, the process will need to tokenize the text to get a set of tokens. In this stage, we usually reduce the number of terms to 0 tokens, removing that seems which are not relevant to the document. If our vocabulary contains too many words, many of them may not be related or relevant to the context, hence such words can be removed. We will spend many resources and our DTM could be useless to the process if there are many irrelevant words. This is a diagrammatic representation of the term document matrix. Count vectorizer. Now it is time to convert a collection of text documents, which was our tweets as discussed in the previous slide, to a matrix of tokens or word counts. If we do not provide a priori dictionary, which is basically a predefined dictionary, we do not use an analyzer that does some kind of feature selection, then the number of features will be equal to the vocabulary size found by the analyzing data. Which in simple words means that if there is no dictionary predefined, the number of words cannot be reduced and it remains the same. Hence, the irrelevant words cannot be removed from the context. We simply count the times that a particular term appears in the document, and it will be the value of the cell in the document or term. TF-IDF. Another technique to create the DTM is the TF-IDF, or term frequency inverse document frequency. In information retrieval, TF-IDF, short for term frequency inverse document frequency, is a numerical statistic that is intended to reflect how important a word is to a document in a collection or corpus. It is often used as a weighing factor in searches of information retrieval, text mining, and user modeling. The TF-IDF value increases proportionally to the number of times a word appears in the document and is offset by the number of documents in the corpus that contain the word, which helps to adjust for the fact that some words appear more frequently in general. TF-IDF is one of the most popular term weighing schemes today. Naive Bayes. Naive Bayes is one of the most popular and most commonly used terminology. We're going to use a traditional classifier used frequently in text classification, naive Bayes, using multinomial models. The multinomial naive Bayes classifier is suitable for classification with discrete features, such as word counts for text classification. The multinomial distribution normally requires integer feature counts. However, in practice, fractional counts such as TF-IDF may also work. We're not going to describe in detail how these algorithms work. All the details of these algorithms will be discussed in the further upcoming videos. At this moment, we can confirm that it has produced great results in many NLP tasks over the years. Just for comparison purpose, we will build other classifiers for binary classification to check if our model performance is good enough for the particular task. Support vector machine. The objective of support vector machine algorithm is to find a hyperplane in an n-dimensional space. N is the number of features selected that distinctly classifies the data points. We can use SVM algorithm to predict if a tweet is a fake or real. It can also be used in projects like fake news classification or fake news detection. It is just a binary classification problem.